Jai Hind everyone. I am Suvarna Mujumdar, working as an assistant professor in Electronics and Communication Department of Ajay Kumar Garg Engineering College. Welcomes you on a lecture on barrel shifter. Today we are going to discuss about the combinational circuit, that is barrel shifter. So, what do you mean by a barrel shifter? It is a very complex circuitry when we go with this shifter, but it is very powerful when we are going to use it in a application form. So, barrel shifter is nothing but an electronic circuit which is used for fast bit shifting operation. It is similar to the working of a shift register, but the difference between a barrel shifter and a shift register is barrel shifter is a combinational circuit, while the shift register is a sequential circuit where we require a clock for shifting operation. Here, in a combinational circuit, we just give a input data bit and shifting operation or rotation operation is performed using this barrel shifter. So it is an efficient data manipulation for and arithmetic operation wherever, like in microprocessor or in digital processor, we use this barrel shifter for shifting our data. Why we use this? As whenever we require to shift a data, the we use either shift register or this circuit. The advantage of this barrel shifter over a shift register is that it will shift a large amount of data in a one clock cycle. So we can say that the processing speed of this shifter is high as compared to other shift register. So let's move on and see how it will work. So what all the hardware implementation or what all the circuits or components required to design a barrel shifter? So we require a multiplexer here to perform the desired operation, whether we want the data should be shift left, right, rotate, like this, or even we form for arithmetic operation also. And if we go with the logic gates, we are use logic gates also to perform this barrel shifter circuit designing. So the primary operation which a barrel shifter will perform will be rotate right. The whatever the number of bits, for example, if we take 4-bit data, we have to shift it right, so that an operation, the shifting left and shifting right will be similar to the multiplication by 2 or division by 2. So in the power of 2 we are going to do the operation. So rotate right or rotate left. Even we can perform a shift right logically and shift left logically, that is a 1-bit position should be left or right shifted. Also barrel shifter is used with for arithmetic right and arithmetic left, that is with the addition performance, or if we want to go with some arithmetic operation, then it is arithmetic shift operation, that 2 4 6 8 if we have to perform like this. So how it will going to do that? So the hardware implementation of this barrel shifter is it consists of a multiplexer. So to design a barrel shifter, either we can go with 2:1 multiplexer, 4:1 multiplexer, or 8:1 multiplexer. Not beyond that, but because it will increase the complexity of the circuit. So for designing a barrel shifter, either suggest to have a 2:1 multiplexer combination, 4:1 and 8:1. Now, how many 2:1 multiplexer or how many 4:1 multiplexer will be required? So, for calculation of that, we are having a relation n log 2n, where n is the number of bits for which we have to design this barrel shifter. So, if we take 4-bit, suppose we have to perform a shifting operation or rotate left or right operation for 4-bit data. In that case, and let's suppose that we have to use 2:1 multiplexer. Okay, so 4-bit data means 4 into log 2 4. So that is equals to 4 into 2, that is 8. So 8 2:1 multiplexers are required to design a barrel shifter for 4-bit. If we go with 8-bit, then in that case it is 8 into 3, that is 24. 2:1 multiplexer will be required to design an 8-bit. We are not going for more than 64-bit because right now our processor, microprocessor where we use this barrel shifter, that is a 64-bit processor. So we have to design a barrel shifter with 64-bit. Then in that case we can go with the 8:1 multiplexer also. So here for example, this is a block diagram for or hardware implementation of a barrel shifter which is using 4:1 multiplexer. So here we have two selection lines. So these two selection lines S1 and S0, this will decide the operation, how it going to be performed, and these are the data, that is the input line which we are going to connect. So let's see, take an example, and from this circuit we can demonstrate how the barrel shifter works for a rotate right operation. So here let's take S1 and S0, and the output will be our Y3, Y2, Y1 and Y0. These are our output lines, and our inputs are W3, W2, W1 and W0. So let's suppose if we are giving an input control logic, that is the selection line 0, 0. So in this case you can see that when it is 0, 0, the Y3 is connected to W3, Y2 is connected to W2, Y1 is connected to W1 and Y0 is connected to W0. What it means that whatever the input you are going to apply, that input is available at the output. So we can say that the input is directly giving to the output. So we can say here there is a no operation took place. There is no shifting operation or right or left. Now if I have to shift the data, or from this you can say if S1 is 0 and S0 is 1, that is 0, 1. So input 1 is selected in all the cases. Okay. So Y3 is connected to input 1. So here we can see that it is connected to W0. So here for 0, 1 combination, Y3 will be W0 and Y2 will be W3, Y1 will be W2 and Y0 will be W1. So you can say that it is a right shift operation. Shift right by 1. So I can write here in this way, it is R by 1. 1 position shifted right. Now if I go with 1, 0, the second, so here it is connected to W1. So it is W1, Y2 is connected to W0, Y1 is connected to W3 and Y0 is connected to W2. Okay, so it's right shift by 2 position. Here right shift by 2 position. Now it's 1, 1. Now in this case, this will be connected to W2. This is connected to W1, W0 and W3. So here you can say right shift by 3. Okay. So shifting right, so this is a barrel shifter where we select the line and we will perform a right shift operation. If we have to perform this should be a left shift operation, then in that case the connection, the input connection will be changed and we have to change this selection lines combination also. So here with this connection, the barrel shifter is used for right operation. So depending on which type of operation we have to perform, we have to connect the multiplexer in such a way that the output of multiplexer will be the input of other and there will be a connection without any clock. So in a single clock, all these multiplexer will work parallelly, and we get an output at one clock, or we can say at one instant of time. As we say that barrel shifter is a combinational circuit, so it gives whatever the present input will be there, it performs the operation on that present input and will give the output. So the advantage of why we go with this barrel shifter in place of any other circuitry is that it performs the shift operation in a single clock cycle. If we are going to control it using a clock pulse, then also the operation took place in a one clock cycle only. They can shift in any number of position. To design an n bit barrel shifter, we have to increase the number of multiplexer only. The connection will be increased, the circuitry will be there, but at a time we can perform in any number of position to be shifted. So for example, at the same instant I can go with 3-bit shifted. Here we can go with if I select 1 operation, I can shift the data instantly by 3-bit. In case of shift register, to perform the 3-bit operation, we have to give 3 clock cycles. But here with single clock, we go with the 3-bit shift. If I have to perform a 2-bit shift in a single instant with the selection of 1 0, I can perform a single shift. So here we can shift any number of position. From here 4 bits are there, so first position to second, first or third, 3 position shift. So 3 operation. If we go with 8-bit data, then in 8-bit also we can go with 6-bit position shifting or 7-bit position shifting. Here rotation as well as shifting both took place simultaneously. Now we can scale also, we can implement any number of bit. I told you that barrel shifter will be designed with an n bit. But with this advantage, there are some disadvantage, and the disadvantage is the complexity. As we increase the number of bits, 8 bit, 16 bit, 32 bits, then in that case we require more multiplexer and more complex circuitry. As the number of multiplexer and circuitry increases, the complexity and design and implementation increases, as well as the cost also increases, because whenever we go with the number of register multiplexers increasing, the number of components increase and it will be more complex. Now as compared to smaller, we have a power consumption also. So number of components multiplexer works at a time. So there are, if 64 components are working at a time, the power consumption is also increased. So barrel shifter will consume more power. But instead of these disadvantage also, but we use barrel shifter in the following circuitries. The applications are, it will be used in network processing, where we have to handle the data packet manipulation and routing. So there we use barrel shifter for routing our data packets. Now here the condition is that the size of our packet is freezed. So we can say that for 8-bit packet size, our circuitry is not that much complex and not that much costly. So we use barrel shifter for network processing. In CPU, where arithmetic logic operation is performed using ALU, there we use a barrel shifter for arithmetic and logical operation, and one of the shift register, that is the temporary register in our microprocessor, that perform this barrel shifter operation. So we use barrel shifter in CPU design also, as well as in graphic processing also, to optimize the image rendering and manipulation. We use barrel shifter. Now thank you.